Robotics is a field that combines science, engineering, and technology to create machines called robots that perform or mimic human actions. Robots have long been a source of fascination in popular culture. R2-D2. Optimus Prime is a robot. WALL-E. These exaggerated, humanoid robot concepts often appear to be caricatures of the real thing, or are they more foresight than we realize? Robots are developing cognitive and mechanical capabilities that do not rule out the possibility of an R2-D2-like machine in the future. The scope of what is considered robotics expands as technology advances. In 2005, 90% of all robots were working in auto factories assembling cars. These robots primarily consist of mechanical arms that are tasked with welding or screwing on specific car parts. Today's definition of robotics has evolved and expanded to include the development, creation, and use of bots that explore Earth's harshest environments, robots that assist law enforcement, and even robots that assist in almost every aspect of healthcare. As artificial intelligence and software progress, we're bound to see the robotics industry's promise sooner rather than later. Robots will continue to become smarter, more flexible, and energy efficient in the near future as these technologies advance. They'll also remain a key focus in smart factories, where they'll tackle more difficult challenges and contribute to the security of global supply chains. Though still in its infancy, the robotics industry holds out the promise of progress that science fiction could only dream of. Robots will be found performing tasks that humans could never accomplish alone, from the deepest depths of our oceans to thousands of miles in space. What are the workings of robots? Robots that are self-sufficient. Independent robots are capable of operating completely autonomously, and without the intervention of a human operator. These usually necessitate more intensive programming, but they allow robots to perform dangerous, mundane, or otherwise impossible tasks, such as bomb diffusion and deep-sea travel, as well as factory automation. Robots that are self-sufficient have proven to be the most disruptive to society, eliminating low-wage jobs while opening up new opportunities for growth. Robots who are reliant on one another. Non-autonomous dependent robots interact with humans to enhance and supplement their already existing actions. Although this is a relatively new form of technology that is constantly being expanded into new applications, advanced prosthetics that are controlled by the human mind are one type of dependent robot that has been realized. What are the main components of a robot? Robots are designed to meet a wide range of needs and serve a variety of purposes, and as a result, they require a wide range of specialized components to complete these tasks. However, several components are essential to the construction of every robot, such as a power source and a central processing unit. In general, robotics components can be divided into 5 categories. Control system. All of the components that make up a robot's central processing unit, also known as its control system, are included in computation. Control systems are programmed to tell a robot how to use its specific components in order to complete a task, similar to how the human brain sends signals throughout the body. From minimally invasive surgery to assembly line packing, these robotic tasks could be performed by robots. Sensors. Sensors provide stimuli to a robot in the form of electrical signals, which the controller processes and allows the robot to interact with the outside world. Video cameras that act as eyes, photoresistors that react to light, and microphones that act as ears are all common sensors found in robots. These sensors allow the robot to capture its surroundings and process the most logical conclusion based on the current situation, as well as relay commands to the additional components via the controller. Actuators. A device can only be considered a robot if it has a movable frame or body, as previously stated. The components that cause this movement are known as actuators. These parts are made up of motors that receive commands from the control system and work together to carry out the movements required to complete the task. Actuators are made of a variety of materials, including metal and elastic, and are typically powered by compressed air, pneumatic actuators, or oil, hydraulic actuators, but they come in a variety of formats to best fulfill their specialized roles. Power supply. Power is required by robots, just as it is required by the human body to function. Stationary robots, such as those found in factories, may be powered by an AC outlet, but they are more commonly powered by an internal battery. Most robots use lead-acid batteries because of their safety and long shelf life, but some may use the smaller but more expensive silver-cadmium variety. When designing a robot's power supply, safety, weight, replaceability, and life cycle are all important factors to consider. Pneumatic power from compressed gases, solar power, hydraulic power, flywheel energy storage, organic garbage through anaerobic digestion, and nuclear power are all potential power sources for future robotic development. What is the use of robots? Robots have a wide range of applications, making them an excellent technology for the future. Soon, robots will be practically ubiquitous. They'll be in our hospitals, hotels, and even on the roadways. Manufacturing. The manufacturing industry is likely the most well-known and oldest user of robots. These robots and cobots, bots that operate with people, test and assemble things such as automobiles and industrial machinery. More than 3 million industrial robots are currently in use, according to estimates. Private use. It's no longer science fiction. Robots can be seen in our homes, assisting with household duties, reminding us of our routines and even entertaining our children. Roomba, the self-driving vacuum cleaner, is the most well-known example of a household robot. Furthermore, robots have advanced to the point that they can now perform everything from mow grass independently to clean pools. Logistics. Robots for shipping, handling, and quality control are quickly becoming a necessity for most merchants and logistics firms. Logistics businesses utilize robots in warehouses and even on the road to help maximize time efficiency, because we now demand our products to arrive at lightning speed. At the moment, robots are removing your things from shelves, carrying them across the warehouse floor, and packaging them. Furthermore, the rise of last-mile robots that carry packages to your door autonomously, ensures that you'll have a face-to-metal encounter with a logistics bot in the not-too-distant future. Travel. Is there anything more science fiction than self-driving cars? These self-driving cars aren't simply a pipe dream anymore. Self-driving vehicles are taking the world by storm, thanks to a combination of data science and robotics. Tesla, Ford, Waymo, Volkswagen, and BMW are all working on the next generation of transportation, which will allow us to sit back, relax, and enjoy the journey. Uber and Lyft, two ride-sharing businesses, are developing autonomous rideshare vehicles that do not require humans to operate. Our healthcare. In the healthcare industry, robots have made huge achievements. From robot-assisted operations to bots that help people recover from injuries in physical therapy, these mechanical wonders are used in almost every facet of healthcare. Toyota's healthcare assistants, which help individuals regain their ability to walk, and TUG, a robot built to independently stroll through a hospital and deliver anything from medicines to clean linens, are two examples of robots at work in healthcare. Would you like to see more videos about robotics? Feel free to leave us a comment.